3.4 is APY. This one should be fairly short. So APR is annual percentage rate. You've probably seen that before if you've ever looked at credit cards. It's the total interest that will be paid in a year. If the interest is paid in smaller time increments, then you have to divide it up. We usually do things by the month. So for example 1, a 6% APR paid monthly would be 6% divided by 12, or 0.06 divided by 12, which is 0.005, and that would be 0.5%. That's the monthly interest rate. Now, annual percent yield is the actual percentage a quantity increases in 1 year. It can be calculated from APR as follows. APY is equal to parenthesis 1 plus APR over K, close parentheses to the K, minus 1. K is the number of compounding periods, so this is a little tricky because we used N before, so think of K as the same as N. I don't know why they had to throw another letter in there, but that's what we have. So this is equivalent to finding the value of $1 after 1 year and subtracting the original dollar. I don't think that makes any sense really, but one way you can think of APY is a way to compare interest rates when you have different rates and different compounding periods. If you're just looking at two different rates, like if I say which one is a better deal, if you're investing money 2.3 or 2.4%, this one is going to be the higher percent, so makes more money. Now, if you're borrowing money, then you'd want it to be 2.3%, so better if borrowing, because you want to pay less money in interest rate. But what if I give you one that's, you know, these have the same compounding period, so the only thing you have to look at are the rates. But what if I told you the 2.3 is compounded monthly and the 2.4 one is compounded daily, or biannually, I guess would make more sense. Then it would be harder to tell which one was better. So that's what we use the APY formula for, so we can compare rates like apples to apples. So let's just practice with the formula. Find the APY for a loan with 2.3% interest compounded weekly. So APY is equal to parentheses 1 plus the APR is going to be the interest rate that they give you, so 0.023. K is the compounding period, so weekly is 52. And then you raise it to the 52nd power and subtract 1. So I'm going to go over on the other screen here and put that into Desmos. Parentheses 1 plus 0.023 divided by 52. Close the parentheses. Go into exponent mode, put 52, get out of the exponent mode, and then minus 1. I got 0.02326. So to make that a percent, we do 2 hops to the right, or multiply by 100, and it's 2.326%. I didn't have a specific rounding there, so 3 decimals is fine. And you'll notice that's awfully close to what the original APY was, or the APR. So now we'll do one where we're going to compare a couple of different rates. So we have one bank, Bank A, is offering, Bank A offers an account paying 1.2% APR compounded quarterly, and Bank B offers an account paying 1.1% compounded monthly, which is offering a better rate for an investor. So an investor wants to make more money, so an investor wants the higher rate. And then keep in mind, if you're the borrower, you want a lower rate. So you always need to know whose perspective, because if I'm going to a bank and I'm borrowing money, the bank wants me to pay more in interest, but I want to pay less. So if it's not clear when they're asking you this, if it's which one's a better deal, if it's not clear if it's the borrower or the investor, then just make sure you clarify to see. All right, let's look at Bank A. Bank A, the APY is going to equal parentheses 1 plus 0.012 divided by 4, because it's quarterly, all raised to the 4th power, and subtract 1. And then I'll figure out what that is in a moment. Bank B is APY equals 1 plus 0.011 divided by 12, because it's monthly, to the 12th power minus 1. So I'm going to go over on the other screen, and I'm just going to edit the last one I had in here. So put a 1, 2, change that to 4. So this one is equal to 0.01205. So that's 1.205%. I'm going to highlight that. And then this other one, I'm just going to edit again in Desmos. This one comes out to 0.01105 or 06, I guess, around there. So that's 11.06%. No, 1 point. Just do 2 hops, 1.106%. All right, so again, we're looking at this in terms of the investor. So for the investor, this one is better. So it might seem like we started with 1.2 and we basically got 1.2. And then with Bank B, we started with 1.1 and we essentially got 1.1. But if you change, you can mess with those compounding periods, and you can get it so that the 1.1 is actually a worse or a better deal for the investor than the 1.2, just depending on how many compounding periods. So for example, if I put daily compounding in that one, so I'm just changing my K to 365. Oh, actually, even with 365, it's still less. Well, I guess it's a bad example, but there are some examples where, depending on the compounding periods, the one could be a better deal than the other, even if one starts off lower or higher. And of course, there's a spreadsheet for this one as well. And you can see that we come up with, I rounded a little differently in that spreadsheet, but same answers.